Alright, let's get started with the practice problem that we did in the class. In this first problem, there is a German airport and the travelers leaving the EU have to go through the security process at least up to 4 times. The first question asks, what is the probability that the passenger who is guilty of the security violation makes it past the gate? That is the first 3 steps. In the first 3 steps, the chance he's get recognized is 50% in the first, 90% in the second, and 30% in the third. So the question is, what is the chance he makes past it? One way to do it is, which of the 2 models that we use in the class can we use here? The first model, if you remember, is making a computer. For the computer to be good, every step has to do it right. The second is the Swiss cheese model. For something to be right, only one of them has to do it right. So here, if we think it's easy to do it if we think it from the guy who is guilty of the security violation. For him to come out undetected, he has to do it right. That he should not get detected in any of the 3 steps. So there are 3 steps. So we are asking for the yield of this process. We want the yield of this process. From his perspective, the yield in this step is 50%. The yield in this step, that is, he doesn't get detected, is 10%. The yield is 70% in this step. The question is, what is the probability he goes undetected? Well, it is just, if we are given the yield of 3 steps and we want to find the yield of the process, all we have to do is multiply all 3 yields, giving us 0.35. The rather easier way to do this, and also useful for the second one, is the decision tree model. Using the decision tree model, in this case, if you want to do it this way, the first step, he might get caught or he might get not caught. If he gets caught, if he gets he might get caught, he might get caught or he might not get caught. The chances of getting caught is 50%, and the chance of not getting caught is 50% too. Right? Use a different color now. So if he gets caught, the problem is, it's done. We are not worried because in this problem, we are asked what's the problem he gets past the security gate. That means he should not get caught in the first 3 steps. Well, if he doesn't get caught in the first step, in the second step, one of the 2 things can happen. He might get caught or he might not get caught. The probability of getting caught is higher here, is 90%. The probability of not getting caught is 10%. Well, if he is caught there, it's done. There is no need to go any further. If he is not caught here, 2 things could happen. He might get caught or he might not get caught. The probability of getting caught is 30%, and the probability of getting not caught is 70%. So the question had asked, after going past the 3 steps, what is the probability of not getting caught? So our desirable, I'm using that term very loosely, leaf is this. What is the probability of arriving here? The probability of arriving here is 70% times 10% times 30% gives us the same answer. Well, the second question is, what's the probability that the passenger who is guilty of a security violation actually boards the plane? Well, here what happens is, he's already here. Now the 4th step is about to come. In the 4th step, what happens is, there is a 95% probability he will not get called for screening, but there is a 5% chance he might get called for screening. If he is not called for screening, well, he gets past it, right? He doesn't get caught. 99% and 1%. There's a 99. Oh, I'm sorry, that was correct. It was 95. So there's a 95% probability he will not get called. In that case, he will never get caught. It's great. He will not get caught. Not caught. Right? But if he gets called for random screening, what happens is there's a 99% probability he will get caught, but there is a 1% probability he will not get caught. Okay, so what is the probability he will not get caught if we go past the fourth step? Well, he will not get caught if he ends up here. He will not get caught if he ends up here. Question is, what is the probability of ending up here, and what is the probability of ending up here? Well, all it is the probability of ending here is 1% times 5% times 70% times 10% times 50%. The probability of ending here, well, you can even add this part. If this is 90%, the probability that he will not get caught is 100%. That's useless, but that you can add that part. So the probability of ending up here is 100% times 95% times 70% times 10% times 50%. So the first part, this part, is 1%. One percent is 0.01 times 5%, 0.05 times 70%, 0.7 times 0.1 times 0.5. This probability plus the probability of ending up here is 1, that is 100%, times 95% times 70% times 10% times 5%. So if you add those two, you will get 0.032675. Then for the test, I will not ask questions where you absolutely have to use decision tree like this, but knowing decision tree might be helpful, at least for the future endeavors. Alright, the next question is, an automotive company is evaluating a capability of one of its key suppliers. The supplier delivers a part of the dashboard which is critical for whatever the company wants the product to be between these two dimensions. Anything outside this is labeled as defective. The question is, what is the capability score? The standard deviation of the production is 0.05. Well, CP is defined as upper specification limit minus lower specification limit divided by 6 sigma, where sigma means standard deviation. Well, your upper specification limit is 110.55, your lower specification limit is 110.45, divided by 6 times the standard deviation is 0.05, so this is 0.1 divided by 0.3 comes out to be 0.333. So the CP has no units, CP is 0.333. Well, the next question is, what percentage of deliveries were likely to be outside the specification limits, outside of the interval? This. But for this, we have to go to the previous chapter. So what the question is asking is, assume this is a normal distribution and the mean is already given to you, that is 110.5. The lower limit is being asked is 110.45. The upper limit being asked is 110.55. The question wants to know what percentage of the product is outside the limit, which means left of this and right of this. Well, the technique is you have to compare this against a standard normal. Standard normal has a mean of 0, and you have to find the equivalence of it. Find the equivalence of 110.55, find the equivalence of 110.45, and find what is right of this and what is left of this. Add them all, you'll find it. So this is basically the method of Z. So we have the sigma here is 0.05, here the sigma is 1. So the technique is to find the equivalent of this. We want the equivalent, let's call this Z1. Z1 is, we're going to find the equivalence of this, so 110.55 minus the mean where it came from, that is 110.5, divided by the standard deviation of where it came from, 0.05, comes out to be 1. Well, let's find the Z2 here. Z2 is, again, we want the equivalence of 110.45, so 110.45 minus the mean 110.5 divided by the standard deviation 0.05 comes out to be -1. Well, our Z2 is -1, our Z1 is -1. If you go to the normal distribution, you will find that the value left of -1, the value left of -1 is the Z value, the percentage equivalent to this Z is 0.1587. So that is what is on this part. Similarly, we want to find what is right of here. If you look at the Z equivalent of +1, it is 8413. So the left of this is 0.8413, which means the right of this is again 0.1587. That is 1 minus this value. So outside these limits, we have 0.1587 plus 0.1587, giving it about 0.3173. The next question is, suppose the supplier wants the CP to be 1.67. How should you change the standard deviation? Well, earlier we used CP equals to upper specification limit minus lower specification limit divided by 6 sigma. Now I want the CP. I want the CP to be 1.67. I have the upper specification limit equals to 110.55. I have the lower specification limit equals to 110.45. And I want to find what sigma do I need to get. Well, if you solve this, this is 1.67 equals to 0.1 divided by 6 sigma, or cross multiplication, 1.67 times 6 times sigma equals to 0.1, or sigma equals to 0.1 divided by 1.67 times 6. Solve this, it comes out to be 0.01. So I need the standard deviation to be 0.01 so that my CP equals to 1.67.